开始最小化。
Okay. Let's see.
Yes. 进入直播间的朋友，欢迎先签到，就是您的姓名加单位。今天的节目呢是用英文来进行。再有30秒，我们正式开始。Okay, today's topic is about global mining giants' response to climate warming, and the topic seems has nothing to do with the common people, because most people think, oh, as long as we talk about how to make a girlfriend, boyfriend, or how to educate our children, how to make money, a lot of people are interested in such kind of topics. But today we are talking about global climate warming. The topic sounds like extremely far from our daily life. Most people maybe don't concern about such kind of questions. Okay, but anyway, this in the past few weeks, I have delivered a lot of presentations about to introduce the annual reports of like Rio Tinto, BHP Billiton, and Vale and Glencore. All of these are very huge mining companies, and I found the same characteristics is that in the contents of their annual reports always include something. For example, carbon dioxide emission, as how much money they spend to deal with the issues. So for small companies or some private companies, maybe they do not concern about these issues. But for the globally mining companies, these giant companies, they may really take social responsibilities, even global responsibilities. And before we talk about the topic, as usual, Joe, please introduce yourself.
Great, thank you. My name is Joe Martins, and I'm a former software engineer, business analyst, marketer, technical writer, presenter that helped Fortune 500 companies for about 20 years. And then I began 5 years ago helping manufacturers in China get their products and services into North America. And for about the past, I've been helping people throughout China to improve their conversational English skills, understanding and being able to communicate in spoken English. And these days I work with Dr. Lyu Guo on doing exactly that through these discussions.
Okay, it's my turn to introduce myself. My name is Lyu Guo, the founder of Suntrans, a translator and consultant in mining and energy. And now let me introduce myself. I specialized in biology at Northwestern University. And after graduation from Northwestern University, I went to teach senior high school English at my home school, that is Donghua Middle School. And at the same time, I studied for my second bachelor degree, English education. And at the end, 3 years later, that's to say 2003, I came to Beijing and studied mineralogy, geology, and mineral deposits at China University of Geosciences. And at the same time, I also work for globally largest mining company BHP Billiton, the largest company in Australia. And also I was jointly cultivated by China University of Geosciences, the Chinese Academy of Sciences, and Miami University in the United States. When I came back to China, I finished my postdoc at Peking University in geology, and also worked for China Geological Survey. This is a government organization and responsible for international cooperation and compared a whole bunch of international mining investment books. And in 2008, I registered Suntrans at the gate of Tsinghua University in Beijing, and also in 2011, I registered Suntrans Consulting LLC in New York. And we have several branch offices respectively in Toronto, Canada, Lahore, Punjab Province, Pakistan, and Kampala, Uganda in Africa. In the past 12 years, I have been in more than 30 countries to help Chinese companies to purchase mines and oil fields. And we also have proofread a lot for scientific research papers. And since 1 month ago, just because the impact for coronavirus, we cannot talk with our clients face to face, and we still to do more to add more value to our clients. And so Joe Martin and I collaborated to do some live stream and sometimes online conversational English training, and sometimes we also introduce similarities and differences between China and America, and sometimes we also introduce some world mineral exploration trends, or and also introduce global mining giants annual reports. And today we would like to talk about very scientific topic that is about global mining giants' responses or countermeasures to climate warming or global climate warming. And Joe, would you like to also introduce why you choose today's topic?
Well, so climate change is on, I think, many people's minds. Even the government of our countries are, trying to address this to various degrees of success. But if you look at modern day government in China, looking at sustainable energy, green initiatives, and trying to come up with ways to, make less of an impact on the environment. So, we're all thinking about it. We're trying to understand it. And I think hopefully today, for anyone who hasn't really followed it, maybe it'll provide some additional information, plus put it in the context of the mining industry and what they're trying to do to help mitigate the problem.
Okay, thank you. And now let's move to the first part. At the very beginning of today's, I want to talk several company, giant mining companies. How did they do, and what have they done? First one, let me introduce Glencore's countermeasures regarding their methods how to respond to the global warming. Responsibility is one of the Glencore's core values. Our commitment to responsibility drives our approach to sustainability, and we put it into practice through prioritizing safety, managing and mitigating our environmental footprint, and positively contributing to local economies. The success of our business and our creation of final value relies on our ability to create lasting benefits for all our stakeholders in a manner that is transparent, sustainable, and respects the rights of all. Here, especially, we must notice here in 2017, 2018, and 2019. From the annual report, here there is one item that is about carbon dioxide emissions, scope 1, scope 2, million tons. So this is their responsibility, and every year they will invest a lot of money in dealing with carbon dioxide emission to theories. For example, in 2019, here is 18.3 million tons of carbon dioxide emission. They have done a lot, and let's see here about carbon. How much money they spend in Glencore? The 2019 they spent 29.2 million tons of carbon dioxide. That is about carbon emission, carbon emissions. This is a very important indicator for the company. They are successful or they are fail. This is their strategy. Our strategy for a sustainable future. So almost no matter for BHP, Valley, Rio Tinto, all of the companies have such kind of requirements. That is, they must make a contribution about carbon emissions. So also community investment, they also spend a lot of money. But at least here, and another several companies spend much more, like BHP Billiton, Vale, and Rio Tinto. What they spend money in dealing with global warming, climate warming, and even much more than here. And let's see here, this is about BHP Billiton. BHP also spend a lot of time to deal with global warming and climate change. Our climate change strategy focuses on reducing our operational greenhouse gas, GHG, that's greenhouse gas emissions, investing in low emissions technologies, promoting product stewardship, managing climate-related risk and opportunity, and working with others to enhance global policy and market response. And they also have here we can say our climate change strategy focuses on reducing our operational greenhouse gas. Climate change is a global challenge that requires collaboration. Resources companies such as BHP, our clients and governments must play their part to meet this challenge. Responding to climate change remains a priority governance and a strategic issue for us. Our board is actively engaged in the governance of climate change issues, including our strategic approach, supported by the Sustainability Committee. Management has primary responsibility to the design and implementation of our climate change strategy, and our performance against our targets outlined below is reflected in senior executives and leadership remuneration. So from 2021, the link between our targets and management remuneration will be strengthened to reinforce the strategic importance of action to reduce emissions. And here also increase some operation emissions. As a major energy consumer, managing energy use, ensuring energy security, and reducing greenhouse gases emissions at our operations are key components of our climate change strategy. We set targets in order to hold ourselves accountable for these goals and regularly review them as our strategy and circumstances change. And here they have their several scopes. Scope 1 about greenhouse gases emissions. 2019, that is 9.7. 2017 is about 10.5. Just because in the past a couple of years, some companies couldn't maybe lose money or cannot make a lot of money, so that they may be reduced a little bit about the sum of money they invest on responding to greenhouse gas emissions. And even our 5-year GHG emissions reduction target, which took effect from January 1, 2007, to maintain our total operational emissions in the fiscal year 2002. Anyway, I don't talk about more details. And all of these, because these giant mining companies spend a lot of money in dealing with global warming, even for our common people in our daily life, we know low carbon daily life is necessary. So we have to recognize global warming doesn't has nothing to do with us. Actually, it has involved a lot of aspects. Okay, Jill, would you like to talk about what your opinions about, no matter to mining companies or to our daily life, what kind of impacts?
Sure.
Okay, please.
Well, I think that for mining companies in particular,
yes,
when you're extracting anything from the ground,
yes,
you're extracting what is basically CO2 that was created a long time ago, whether it was for oil or other minerals, metals that this is not, in other words, CO2 that was generated by plants today, generated by humans today, so much as trapped CO2. And the difference is this: because they're releasing that, because they're pulling it to the ground, and in a sense now releasing it into our current atmosphere, mining companies need to be, aware and able to try to mitigate that, to make it less of an impact. And,
yes.
And so, before, in the last century, most often they weren't particularly concerned about it. It's more recent times that they said, wow, if we keep doing this, it's unsustainable. And so we need to make sure that we have some plan, something. Even a small reduction is a step. And, many scientists seem to debate or not necessarily universally agree on how much is needed, but we all know that something has to be done. So the mining companies, you see in their investments and in their data about their emissions, how they're trying to reduce that amount, to do their part, because they are one big part of that the release and introduction of CO2 into the atmosphere. And it's not the only gas that contributes, but in modern times, it's one of the biggest contributors, as we'll see in the presentation.
Yeah. The signal sounds very weak. Yeah.
Weak signal again tonight.
Yeah.
Having a problem with the signal, I wonder.
Yeah.
Let me just ask the audience, and we can continue on. And then, okay, so
and
basically,
yeah.
This. Oh, go ahead.
Okay,
Go ahead.
Let me introduce a little bit about BHP, because I used to work for BHP. This is a globally largest mining company. I must thankful to the company which cultivated me. It's very, very important during my career experience. And up to now, the company still is number one in the world in mining. Comprehensive index is still number one. Let's say how about BHP is investing in low emissions technologies and defining a pathway to net zero greenhouse gases emissions for BHP's long life assets requires planning for the long term and a deep understanding of the development pathway for low emissions technologies. Our latest strategy is threefold. First, we took to adapt mature technologies such as light electric vehicles in order to integrate them safely and effectively into our operations. Second, in the medium term, we create roadmaps for development and adoption of latest that support our global of net zero emissions, which may include trials and demonstrations of technology in our production environment. Finally, we look for early stage that hold high potential for future results. For these emerging technologies, we seek opportunities for collaboration, research, and other ways to accelerate their development and adoption. And about Scope 3, while reducing our operational emissions is vital. Emissions from our value chain are significantly higher than those from our own operations. We work with our customers, suppliers, and other value chain participants to seek to influence emissions reductions across the life cycle of our products. As we work to develop an integrated product stewardship strategy in fiscal year 2020, we intended to look to identify additional opportunities to work with others in our value chain to influence emissions reductions. We are intended to set public goals and related to scope 3 emissions. So number 1, 2, 3, they have different in different ways. They have taken a lot of measures. For example, here number upstream, downstream, greenhouse gas emissions, purchased goods and services, including capital goods, fuel and energy related activities, upstream transportation and distribution, business travel, employee community, and in all of aspects, they have made a budget for these activities. Anyway, here we have to admit that for BHP we have to admit that BHP has set up great examples for us to recognize. We must every company, mining companies or even other fields companies, also must care how to reduce carbon dioxide emissions. And as we work to develop an integrated product stewardship strategy in fiscal year 2020, we intended to look to identify additional opportunities to work with others in our value chain to influence emissions reductions. We also intended to set public goals related to it. And here maybe we can talk about what's climate warming, global warming, and how is it an average increase in the temperature of the atmosphere near the Earth's surface and in troposphere 1, which can contribute to changes in global climate patterns. So that means the climate is becoming warmer and warmer. I remember when I was young, maybe only 10 years old or 15 years old, in the winter it's very, very cold. But nowadays it seems not as cold as before. And another one is about in China there is a Qilian mountain. Qilian mountain, the snow line seems also reduce, also becomes lower and lower. It also means that a lot of ice and snows have been melt, and so what becomes the temperature of the weather becomes higher and higher compared to several decades ago. So, Joe, would you like to talk about your opinions?
Sure. So, the troposphere,
yes,
is approximately the first 10 miles or 10 kilometers, about 6 or so miles of the atmosphere.
Yes.
And that's basic. Think of it as when you take an airplane, when you take a flight.
Yeah.
Most airlines fly in the troposphere.
Yes.
And about 99% of all moisture is below the troposphere or below.
Yeah.
And that is affected by that next phase, that stratosphere.
Yes.
The stratosphere goes from about 10 kilometers to about 50 kilometers. And in there, that's where you've got your ozone layer. And the depletion of that ozone layer, the changes that have occurred, have caused a couple problems. One is that the planet, when we say warming,
Yeah.
we don't mean 20 degrees. We mean fractions of a degree.
Yeah.
But those fractions of a degree have a huge impact on sea life, on air quality, on many different things that just 0.2 degrees, 0.5 degrees
Yeah.
have a major impact. So, as a global scale, not individual, not, just the northern United States or just the southern South America.
Yes.
On a global scale, the average trend in temperature has been going up
Yeah.
about 1.5 degrees in the past century, the past 100 years. That's huge. It doesn't compare necessarily to the Ice Age, but in the short span of time of just about a little over 100 years, but a very short span of time, the temperature changed dramatically. So that's what we're talking about now, is this change and the impact, especially in that troposphere below the ozone layer.
Okay. Here, I guess a lot of people are thinking why. What reason caused the globe, the Earth, becomes warmer and warmer? Now we can list several points. Reason one is burning of fossil fuels, coal or crude oil, and power plants generate electricity. For example, we use a lot of coal to burn it and then use it to generate electricity. The second is transportation. Fuels for transports, for example, fuel oil, kerosene, LPG. During the course of transportation, fuels, that means will cause will cause the weather or the climate become warmer and warmer. The third point is industrial process, manufacture of cement, steel, aluminum. If we want to refine steel, that means during the we must build up smelting plant or beneficiation plant. That means during the whole process it will produce a lot of energy so all of these reasons will cause global warming. And do you want to talk more about this point?
Yeah, so one of the very interesting things, and I had to look this up. I didn't know the answer immediately.
Yeah.
And that is, remember yesterday when we were talking about weight loss, and we said human beings breathe out CO2 and H2O, water and carbon dioxide. Carbon dioxide is part of the greenhouse gases. It's what many of these things like power plants, transportation, industrial processes, they all emit CO2.
Yes.
Among other gases. So, but we do too. But the question was, what do we contribute when we breathe out, because we breathe out CO2? Do we contribute to greenhouse gases? It's a good question.
Yeah.
And the answer is we don't. Here's why. We are in the present time.
Yeah.
Remember the other thing we said yesterday. Plants consume the CO2 that we breathe out. They convert that CO2 with the oxygen into sugars.
Yes.
With the water into sugars. So plants are breathing it in or taking it in. We're breathing it out. So there is a net exchange between us and plant life on this planet.
Yeah.
that means that adding, we're not adding to the CO2 global warming. Difference is what I mentioned earlier. When you're mining, when you're burning fossil fuels, you're burning CO2 that was created, in some cases, millions of years ago. It's been extracted from the ground, and now you're burning it into the modern day atmosphere. Before, it was trapped in the ground, so it wasn't a problem. Same thing with ice. As ice melts, old ice, not new ice, I'm talking about old glaciers and ice hundreds of feet thick that have been around for centuries. That ice also traps old CO2. When that ice melts, that CO2 gets released into the atmosphere. So us, our breath, yes, we do breathe out CO2. No, we don't contribute with our breath to the global warming. That's all old CO2 generated, trapped a long time ago that we're releasing now. So that's the main difference. When you look at these causes, all of these causes
beside the above, the fuels, when we burn these fuels, it causes global warming. And what's more, are the greenhouse gases emission, agriculture, forestry, other land uses, waste management also cause a lot of gases emission.
Livestock in agriculture, just all of the pigs and cows that are generating huge amounts of new gases from their conversion of usually into like methane. But the livestock industry, some of these farms, if you ever lived near a farm, a large farm, you can smell it in the air. There's a huge, it's not like our breathing. But those animals too are largely converting what they're eating into those emissions. So it's mostly the more industrial, any kind of petroleum or coal, extraction and burning. That's where a large amount of the old CO2. And remember, I call anything that was trapped in the ground for a long time, that was created a long time ago, millions of years, hundreds of thousands of years. That's the CO2 that's making its way into the atmosphere now through industrialization, through our use of all of these petroleum type products, gasoline and oil, kerosene, diesel, etc. So and that's why earlier we said the mining industry pays more attention now, right? Because their products are part of what generates it, and so they try to offset the impact, try to minimize the impact.
Yes, and as we know, in our daily life, we can also take some examples. It causes global warming. That is, using natural gas to cook. When we are using methane plus methane, for example, CH4 plus oxygen, it will produce carbon dioxide and water. So besides the carbon dioxide, other gases such as methane, chlorofluorocarbons, nitrogen oxides, and ozone also contribute to the greenhouse effect. Actually, at home every day when we are cooking, the process that is produce a lot of carbon dioxide. And it's very important almost every day in our but in rural area in China, maybe a lot of people are still burn some dry dry wood or some branches of tree But actually, more and more places are using natural gas in China, and in other countries, I guess the same. So a greenhouse effect happens everywhere. So can you talk more about this point?
One of the best parts about this slide, I love in that equation. You look at that equation, it's very similar. The right side of the equation, just like the weight loss equation from yesterday's discussion.
Yes, it's the same.
Because those
how to lose weight is the same.
yes. those two products, whether they come from us, or from industrialization, or from agriculture, it's basically the same two products. But in this case, is on a scale that's massive. I saw a statistic that said that the current global emissions for CO2 is the equivalent in weight if you were to weigh the gas. Because remember, CO2 has a molecular weight.
Yes.
So if you were to weigh the gas that's emitted by everything globally, it weighs about as much as 2,750 Empire State Buildings in New York City. Almost 3,000 Empire State Buildings. The weight of that building. That's how much CO2 we put into the atmosphere every year globally. That's amazing. I can't. It's beyond. I can't even imagine it, because if you look at a pound of CO2, one kilogram, 2.2 pounds, it would be a massive amount of gas. many cubic meters of gas. So we release an enormous amount of this gas into the atmosphere each year. And if we don't stop doing that, someone pointed out in the comments, public transportation. Good point. You want to try to move away, like the U.S. was based mostly on cars for a very long time. 100 years, more than 100 years. So we have been a car-based society where every family wants to have 1, 2, 5 cars. Chinese society grew up around bicycles, the idea of scooters, taking public transportation, very different. So already in Chinese society, you have that correct mindset of, try to minimize cars. And try to maximize moving people around with public transportation. So the U.S. can learn from this. And say, maybe more trains, high speed, any kind, more trains. More metros, more, in cities where we have subway, metro. Maybe more new metro lines. Because I know in Shanghai, in Beijing, I can take metro everywhere. But if I go to Boston or New York, you can get to some places, but not as many as you can in China. So we have much to learn in order to reduce how much we're emitting for carbon dioxide and other gases.
Okay, here because today we have a lot of audience. They are from different backgrounds. Some maybe studied art, not science. And let's talk a little bit details about greenhouse effect. We know greenhouse effect is one of the essential reasons for global warming. Usually that means we know greenhouse gases in the atmosphere. Some infrared radiation is trapped close to the Earth, or on the surface of the Earth, and they cannot go out, send out. So that is a greenhouse effect. Would you like to make more interpretation or explanations regarding greenhouse effect? About the theory or the phenomenon?
So most people kind of understand at this point that within that troposphere, these gases are trapped, and that contribution to the depletion of the ozone layer as a result means a couple things. We can't regulate the temperature of this planet very well, not as well as it was regulated previously. So a couple results of that, you've got more sunlight able to get through that atmosphere. So when the sun is on your side of the planet, like right now it's daytime there and it's nighttime here. So as ozone is depleted, you're going to have less ability in the sunlight to regulate that heat. It's going to be much hotter over time. And that's going to cause issues with being able to grow plants, being able to keep cool and not become, toast. When the sun is shining on that part of the planet, it means heat is a problem. Too much heat. Now, on this side, we're dark right now, it's nighttime. We've got the other side of the problem. We've no sun, no protection from the cold, when that sun that we relied on to heat up the planet, and then the ozone layer keeping it nice and warm, toasted. Even when there's no sun, right? So the sun goes around the other side, and we're still basically warm enough. Without ozone, you can't trap that, without that layer, you can't trap that heat effectively. And you end up having cold, extreme cold, when the sun is not shining on you. So you've got the two problems. As that sun, or as the earth goes around the sun, whatever isn't in the sunlight is going to be much colder. And whatever is in the sunlight is going to be much hotter. So unfortunately, over the next 50 to 100 years, we are very worried about how we're going to regulate that temperature, the difference in daytime and nighttime on the planet. And it affects everybody, because in 12 hours, you're going to be nighttime and we're going to be daytime. And so we'll be dealing with the heat 12 hours from now. So this is a global, it's not a U.S. or China or Australian problem. It's an everybody problem.
Yes, everywhere. Increase in greenhouse gases, concentration of greenhouse gases in the atmosphere is highly increased by human activities, leads to the increasing seriousness of global warming. Just ago, we have mentioned some human beings' activities like cooking or transportation or to burn some fuels. All of these activities may produce it. And we can also see one graph. We can see from 1955 to 2005, the carbon dioxide concentration ppmv, it increased a lot. In maybe 100, about 100 years ago, the concentration for carbon dioxide is about 315 ppmv. But about 15 years ago, the number has become 385. Oh no, 375. So in great degree, the concentration of the carbon dioxide increased greatly, and the carbon dioxide concentration as measured at Mauna Loa, Hawaii, or even China. These measurements represent the global mixed concentration. We have to say, of course, this data the source is from Dave Keeling and Tim Wolf. This is about oceanography, Scrip Institution of Oceanography.
Right.
Yeah, and so global surface temperatures also increased a lot, increased about 0.6 degrees Celsius since the late 19th century, increased to 2 Celsius degrees century over the past 25 years. Maybe up to now even more. So that means the temperature and the climate really are becoming warmer and warmer. So would you like to give me some interpretations?
Yes, so chart that you showed a moment ago was up until 2005, but you can see the trend upward. Well, as of last year, it was that if you were to continue graphing this, as of last year, it's up to 407.
Oh, 407, you mean 2019? 2019. You mean the
2019.
Concentration of carbon dioxide. Wow. It increases sharply.
To give you an idea, to give you an idea of how bad that is, the estimate that scientists have today is that the Earth has not had that concentrated 407 parts per million for the last 800,000 years, nearly a million years. Since we last had that much CO2.
Remember
what I said.
That is to say, every year it increases the concentration of carbon dioxide increases maybe about 1. So in the past almost 95 years, it increases. You mentioned about 407. That means 1 year increase about 1 ppm way every year, almost.
And if you think about that CO2 that used to be in the atmosphere a million years ago, it got trapped in rock, it got trapped in waters, it got trapped in ice, it got trapped below the surface of the planet, away from us over time. So you end up having less CO2 in our air for the last million years. But we're rapidly releasing it back up into the atmosphere. And creating a situation that the Earth hasn't had in almost 1 million years. That's amazing. We're creating an environment, an air, that hasn't existed in this concentration on the Earth since a million years ago. And so many scientists are saying, we're guessing, we have some ideas, some very educated ideas about what the impact will be. But one thing they know for sure is that the atmosphere hasn't been this bad for almost a million years.
And just ago we mentioned one number. So the global surface temperatures increased about 0.6 Celsius degrees century since the late 19th century, increased to 2 Celsius degrees century over the past 25 years. So generally speaking, it has become warmer and warmer. Increase in global temperatures here. We can also from the graph we can say degrees anomalies in the 1880s to 1920s. During the process, we can say the anomaly seems still minus. Here, no matter ocean, land and ocean here, the above one, and for ocean, most number here, National Climate Data Center, we can see anomalies still minus. But in recent years, since the anomaly seems from it has converted from negative to positive, or from minus. In the past, just minus. But since the last 1950s, gradually, or 1940s, all of the data, the anomaly, the degree C anomalies or degree F anomalies. Anyway, both we can say the all become positive. Even the number become increased a lot in the past 70 years. In the past 70 years, all of the numbers become positive instead of minus. So that means it increased a lot the temperature. Do you want to talk more? Yeah,
if
please.
You think about well, if you look at that period of time, what kind of events began right around the late 1800s, early 1900s? It was the emergence of heavy industrialization and an increase in the use of things like fossil fuels.
Yeah.
So, you had a population that was going from big to really big.
Yes.
And you had to produce food. You had, the introduction of automobiles,
yes,
railways, huge factories. Many things began in around that time frame, and so it flipped. It went from a net, temperature, a low temperature, to a net higher temperature.
Yeah.
Even though we're not talking about 20 degrees. If it was 20-degree difference, we'd all be dead.
Yeah.
We cannot have a 20-degree difference. All it takes is fractions of a degree. The current estimate is that a full 2 degrees would be devastating to the ocean. Part of it, think of this.
Yeah.
As the planet's warming, even just a little bit,
yeah,
the ice that trapped a lot of old CO2.
Yeah.
So, when we burn fossil fuels and create some of the gases that heat the atmosphere, that in turn melts ice.
Yes.
And that ice releases other gases, not the same gases. These are gases that were trapped in vast quantities.
Here
in the ice.
Yes. Here I would like to talk about some specialty. Really specialty. That's I specialized when I was in the United States. I studied geomicrobiology. That is the interaction between bacteria and rocks. And one of I also stayed 2.5 years in Chinese Academy of Sciences. That laboratory particularly researched about extreme microorganisms. That is, some some microorganisms like including a virus and bacteria. They can live in extremely low temperatures. Even minus 20, they are still still alive. And in the maximum nowadays. For most bacteria and life, as long as we heat them in the boiled water about 10 minutes, 99.99 life will be killed. But some life can exist in very high temperatures. For example, in some warmer spring or fountains, spring in Yunnan province, China, we can say the water is very hot, even 50 degrees, 60 degrees, 80 degrees, even boiling. But still some extreme life still exists over there. That is, they can endure very high temperature. Of course, some can endure radioactive. Some can endure the pressure. Some can endure. Anyway, they make use of different energies, so this is extreme life. In certain very terrible or nutritious is lack of certain nutrition. They still can use some other energy or food as food. And for just as far as the temperature is concerned, for you the maximum temperature for certain life for bacteria, they can endure 123. This is up to now. This is because I spent a lot of many years, about 5 years. I researched. My PhD dissertation was regarding CCSD, that is China International Continental Drilling Program, and we got a whole bunch of samples, the rock samples, maybe the deepest about 5,500 meters on subsurface, and I crushed the samples into powder, and then try to cultivate, incubate some bacteria and virus, and see what kind of bacteria exist, and detect the lower limit of the life sphere. So I spent a lot of time in doing the research. So here we can say, anyway, the subsphere, the deeper the subsphere it is, the temperature is also increased a lot. That is, there is a gradient of geothermal gradient. The deeper the temperature is higher. So just with the time flying, also the temperature close to the atmosphere, the temperature close to the crust of the Earth also increasing quickly. From this graph, we can see it. And about the temperature difference between different parts to atmosphere, here we can say troposphere temperature, the lowest 8 kilometers of the Earth's atmosphere, collected since 1979, also indicate warming. Cooling effect in higher parts of the atmosphere. Stratospheric temperatures have been decreasing. About here, temperature difference between different parts of an atmosphere. Would you like to talk a little bit more? Even we take a flight in different height. That means outside the temperature is totally different.
And it's not even just the atmosphere.
Yes.
Even when you consider the surface of the planet.
Yeah.
If you look at a heat map
of
the planet up close, so
yes.
I'm talking about zoom in to a specific area.
Yes.
For example, southeastern United States, Florida.
Okay.
In that specific part of the planet, the average temperature there hadn't gone up as much as, or I should say the year-over-year temperature hadn't gone up as much as the Northeast or the West.
Yeah.
And people there say, oh, must not be any climate change because we haven't seen a significant change in our situation.
Yeah.
Well, just like the atmosphere in
Yeah.
different levels of the atmosphere has different impact, different temperatures. On the planet,
Yeah.
The soil, the moisture in the soil, the oceans, and if you are a piece of land surrounded by ocean, that can have an effect on the temperatures in your local area. Even clouds. So clouds, if you have a lot of clouds in an area, that area will experience less of a temperature difference than you would see in cloudless sky. So around the planet, if you only zoom in and look at a region, it can give you the false impression that climate change might not really be a thing. But the way to look at it is to zoom out from the planet and look at the entire planet and the average for the whole planet. And that trend has been going constantly upward. There has not been any trend downward or drop in the temperature decade over decade. It's only been upward. So yes, in different parts of the atmosphere, on different parts of the planet, you might think, based on where you live, that you haven't seen much of a change. But as a whole, it has changed. So scientists are saying, eventually, Southeast United States will see the temperature go up because of that average change throughout the entire planet. Even if they haven't seen it a particular year or at a particular time of year, that doesn't matter. It's the average. So, people in the U.S., some of them will say, no climate change. In Florida, it hasn't been substantially different. But I grew up in the Northeast, which is more similar to Beijing, Qinhuangdao, that area, that climate.
Yeah.
And we have shorter summers, hotter, shorter, summers, fall and spring have gotten shorter. We have more winter and summer. So instead of 4 approximately equal seasons, we have 2 long seasons, summer and winter, one very hot, one very cold, and our fall and spring has become shorter and less, you almost can't tell. It feels, you'll hear people in the northeastern U.S. say, wow, what happened to fall? It feels like we went from summertime to wintertime, and from wintertime back to summertime. And that's how dramatically the climate in just 50 years has changed for the northeast of the U.S. So it's, we can feel it here more than Florida. But Florida,
you are right.
Eventually feel it too.
Yeah, here I would like to introduce one graph that is about MSU troposphere and surface temperature anomalies, and from this graph it covers from 1979 to 2001. And here there are a lot of black lines. The black lines is represents stand for MSU troposphere anomalies, and the red line stands for surface temperature anomalies. Here I can show several peaks and valleys. Especially we can look at in about here horizontal coordinate is the year, the time, and the vertical coordinate here is anomalies, the degree Celsius, the Celsius degree. And in about 1998, all of Chinese people still remember 1998. That means a very terrible flood disaster happened in Hunan province. A lot of people died.
Oh.
Yeah, that year.
Wow.
In China, flood. Maybe in the past several decades, that year, flood happened in China, and so that here we can also see the peak. The peak. No matter the black line or the red line, we can hear in 1998 here the degree is about 0.4. That's why that year I remember that year President Clinton also came to China have a visit, and President Jiang Zemin also spent a lot of time in dealing with the flood, and so that's very terrible. And a lot of people died in the flood just because that year, 1997, 1998, in the 2 years, the temperature is very, very high, especially in June and July, so that the natural disasters also we can make interpretation. We can make some explanation about why the natural disaster happened. Actually, just because global warming. Here we can get the reason. And about several the valleys, not only peaks. Here we can see some valleys. I still remember in 1992 and 3. I was just grade 1 in senior high school, and I remember that several winters it's extremely cold, and winter I felt in my since I was born until now, that several years it was the coldest in my life. I'm 42 years old now, so we can say. So it's coldest. From here, we can also see in 1992, 1903, and 1984. It's the cold, all of the coldest. Maybe 1994. I was still very young, maybe 8 years old. I maybe still knew nothing at that time. But when I was older, maybe about 1994, I know more. And at least from this graph, we can see the temperature. The global temperature anomalies really related to our natural disasters, and we must recognize it's very important. And from 1992 to 2000, we can also notice MSU lower stratosphere temperature anomalies. Annual averages from 1979 to 2001. Anomalies also changed a lot. It was decreased, but the surface temperature anomalies increased a lot. So about atmosphere temperature and surface temperature, it's reverse the different ways. And would you like to take some examples? I'm not sure if you still remember some natural disasters in your memory. Yeah, please.
The thing that my takeaway from graphs like this is no matter year, you cannot look at it by month or even by year. Yeah. Meaning, if someone wanted to pick 1 year just to make an argument, yes, they could say, "Oh, it was much cooler this year," So therefore, there's no global warming. Or someone else that is a supporter of the facts about global warming, they might pick a very high data point and say it's very hot. But the reality is, look at the trend. The trend shows that it's getting warmer in the troposphere and on the surface of the planet. Yes. And so it I immediately, when I see data points, I don't care about the peaks and the valleys, whether it's the stock market or temperatures of the planet. Look at the trend. And in this case, these aren't the only types of trends. If you look at other graphs of that support global warming, you'll see, for example, sea ice. You'll see the freezing and thawing of ice on the planet, and how less and less ice is ultimately staying for a long time. In the past, we would have a lot of ice that stayed for a longer period of time throughout the year. What you see now is we'll get some ice that will return in cold weather, but it will disappear really fast and in really large quantity. So satellite photos show throughout the year, they'll show the surface that froze, and then they will show the surface that thawed. Well, the part that stays, that deeper, thicker ice, that's getting smaller and smaller and smaller. And the part that grows is the temporary ice. It's there for a brief period. It gives you the illusion, when you look at it, at the right time of the year, it gives you the illusion there's a lot of ice. But that's just thin and widespread ice that is thawed super fast throughout the year. So, scientists, when they show photos, unfortunately, people who don't want to believe in this will take specific photos from that, and they will say, look at all the ice that was on the planet in April of 2020. It's like, but you have to explain to them, most of the ice in that photo is not the ice that will be there in 2 months. The ice will be gone, and you'll see the reality, which is a much smaller footprint of the thicker ice, which by the way, is the ice that's holding all the old CO2 for hundreds of thousands of years. That's the most dangerous ice. When that's melting, that's contributing to the greenhouse gases and this temperature increase that you're seeing.
I also have the same. I also had the same experience about ice. I stayed for a whole winter when I was young, but nowadays, very rare, very seldom we can see ice outside, and even the whole night, less and less snows. And not a global uniform warming. Warming parts, North America, Euro, Asia, and cooling parts of the southeastern U.S. And annual temperatures change from 1976 to 2000. We can also see the temperature changes a lot. Increasing temperatures extremes. Regions that have temperatures from 1 to 3 degrees warmer than the average. United States, most of the Europe here, we can say the temperature changes from 1 to 3 Celsius degrees. And the regions that have temperatures from 1 to 3 degrees cooler than the average, that is Australia. Australia is different, the temperature changes in Australia is different from those places, some places such as the United States and most of Europe. This is special places. About regional temperatures, annual temperature anomalies for 2001 in the whole globally, it's also different. Here from the picture, we can see the blue points refers to minus, and the red points refers to up zero, that is positive. We can say in most European places here, all of these places European countries are positive. That is hot spots, a lot of hot spots. But in Australia, we can see a lot of blue spots that represents the minus temperature here. Just as far 20 years ago or 18 years ago, in the Earth, different areas, the temperature also changes. Have different changes, different regions.
Yeah.
Yeah.
And that shows sort of what I was saying before.
Yeah.
That you're not going to get a uniform change everywhere because of the geography of the planet.
Yeah.
But the planet trend will be up. So, just because Australia shows lower temperatures, that just means that the geography of Australia right now is such that they see lower temperatures. But their temperature on average will also increase over time as the average of the planet increases.
Yes, and for sea level also rising because all of the snow thaw and ice also thaw. That means more and more water and rising at the average rate of 1 to 2. So and every year about in the past 100 years, every year. Millimeters, about 1 to 2 millimeters. So that's terrible. So maybe some people say when we visit some island and some countries, maybe another 100 or 200 years later, some island will be covered by water. So it will disappear like some Indonesia. Before this Chinese traditional New Year, I accompanied several Chinese investors, professors, want to visit to investigate several gold mines. And some people say, oh, there are a lot of landscapes in Indonesia and a lot of islands, very beautiful. But maybe 50 or 100 years later, all of these beautiful landscapes will be covered by water, just because rising as a sea level rising, very terrible. Some countries like Japan, a small country, Philippines, a small country, Taiwan area, all of these places maybe gradually will disappear just because of sea level rising. Yeah, and
yep. And if you think about it, over the next 100 years, they're estimating that the sea level rise because they think that the temperature will accelerate.
Yes.
So they think that the sea level rise will get much worse as the large glaciers melt more.
Yeah.
And part of that means, look at your example from the 1990s of Hunan floods.
Yeah.
That happened again in 2017.
Yeah.
In 2017, I looked up, I wanted to see how bad it was. In 2017, over 18,000 homes were completely destroyed by floods in Hunan. And if you look at the total effect in the 8 provinces in China that experienced floods in just 2017, it affected 9.5 million people.
Yeah.
Where homes, businesses, crops just destroyed.
Yeah.
So the it's a serious enough problem that if you look at typical farmland, good farmland is where? It's usually near water.
Yeah.
If the water rises, bye-bye, that farmland's gone. That's now underwater. If you are thinking of going to visit or vacation at a beach, do it now. Because in 30 years, places like Venice, Italy,
Venice
is already experiencing such flooding that many of their most popular tourist attractions in Venice, Italy, are underwater right now.
Yeah.
Because it flooded so badly this year that they're underwater. So, and they don't think that water is ever going to go away completely now.
Right.
So, if you're thinking of investing in property, don't buy property near the water.
Oh.
Not unless you're going to use it. If you want to use it for the next 10 years.
Maybe one day it was destroyed by a flood or because of the sea level rising.
Yes, I would say if you're going to buy it, enjoy it for the next 20, 30 years, and then sell it because it's probably not going to be a beachfront anymore. You know, the new beachfront will be way back there, and your house will be underwater.
Yeah.
So, you know, and I mean, I laugh, but it's very serious.
Yes.
There are many parts of the world where many hundreds of millions of people live close to water in low lying areas.
Yes.
So,
and global warming, and also produce a lot of environmental and human being effects, and it will affect each other. For example, biodiversity may be lost if the become warmer and warmer. Even human beings. In the past 10 years, I have been in Pakistan for many times. When I went to Pakistan and several cities, I found it was extremely hot. And I read the local newspaper and found almost every year a lot of people died for the high temperature, especially in summer. In summertime, a lot of people here dehydrated and died. So the biodiversity loss and ecosystem function will also be affected. And the fresh water will decline. And water quantity and safety also will be affected. And then our human health also be affected, and also produce some population displacement. So in some hot places, people cannot live. They have to move to other places, and so that desertification and land degradation also happens. For example, my hometown Dunhua is called Oasis. It's a small. If we take a flight from the sky, the atmospheres from the sky, we can see our hometown. Just over there is green. Other part, all are mares and mare deserts, and very terrible, very barren, and the land degradation, and a lot of land will become not arable anymore, and so all of these at the very beginning just because of the primary reason is still climate change, global warming. And global warming also have diverse processes, not only for human health, desertification and land degradation, and stratospheric ozone health, and it also produce UV exposure, and directly a lot of people will get cancer just because of ultraviolet exposure, especially in Tibet area, because the sea level is very, very high. A lot of people will be exposed under UV, ultraviolet, so that they get their skin, the compensation will get some ill or cancer, even cancer. So, and also about desertification and land degradation also is related to arable agro ecosystem productivity And a lot of in China, because the population is about 1.4 billion, it's a very huge population country, and we still need a lot of crops, a lot of food. If we cannot, if climate change, global warming becomes worse and worse, that means we cannot have more food. And so anyway, a lot and including sometimes desertification and land degradation also will alter the precipitation, so that no more fresh water. So here global warming will affect many the people and many aspects. Would you like to give some opinions about the graph?
Yeah. What I like about this chart is that first, all the interdependencies.
Yes.
Everything our ancestors around the world knew. Without the science, they just had a feeling that everything was interconnected.
Yeah.
And they knew that there needed to be balance in order to survive.
Yes.
For some reason, over the last few hundred years, so many of us have lost that connection with the planet.
Yeah.
And the interdependencies are still there. They haven't gone away. We just ignore them. And which is very dangerous. You mentioned the desertification and the land degradation.
Yeah.
So that's two things. One, when land's getting flooded and when land is going dry, how are you going to feed 1 billion plus people? How are you going to feed 7 billion plus people? And these people are having more babies.
Yeah.
The population isn't getting smaller. So in 10 years, we will have to feed many more people. But our land is under attack.
Yeah.
Because what we're doing to the environment is attacking that land and making it so that if we don't get more food out of less land, and remember, less and less and less land, if we don't get more food out of it, more density,
you are right.
That would be a problem. And that's just one.
Yeah.
I mean, that chart has 3 other ones. In India, where clean water is already a huge problem. They can't get adequate clean water for their entire population. So there are people there that are experiencing disease because they're drinking from the same water that they're dumping chemicals and feces and other things into. And that water, which is already under attack by them, gets further under attack because the climate change and what's happening to the land, what's happening to precipitation, is now making it more and more difficult to get fresh water.
Yes.
So people like Bill Gates are trying to find, some technology, some solution that they know they're not going to change the habits of 1 billion plus people in India. Those habits are going to take decades to change. It will not happen overnight. So they have to find some technological solution in the meantime. And then educate the people, don't go to the bathroom in the water that you drink.
Yes.
So there's a lot of work to be done with that. But look at how interdependent everything is. And if we continue to not take that seriously, look at where all the arrows lead, all of them. UV sunlight, less fresh water, less agricultural products, fewer biodiversity. It all leads back to our health.
Yeah.
So it's crazy when you get, people that say, it's a hoax. It's like, no, not only is it not a hoax, but if we don't take it seriously, our kids and our children's children are going to be the ones that suffer the most. And so we have to say, okay, we might live okay for the next 20 years, but in 50 years, they're not going to be okay. So we
must consider about our offspring as benefits, as more generations. We must consider for.
And if you're single and have no children, worry about your friend's offspring.
Yes.
Because, do you want to hurt your friend's children? So,
you're right. Too harmful to our human beings, generations and generations. Maybe we can have 30 seconds to have interaction and questionnaire with our audience. That is, let's think about global warming will produce what kind of effects. You can list some points here. And also hopefully you can help us to forward the link to more WeChat groups. 那么请大家帮我们也点上面3个点呢，右上角3个点，再进一步做一点转发，同时也希望能够大家再做一个互动，就是列出你觉得这个全球变暖温室效应这些会产生什么样的循环或者效果，产生什么的后果。那么大家在这儿可以在公屏上呢可以列出一些，我们有30秒到1分钟的时间，谢谢大家。这帮助转发以及列出温室效应及全球变暖产生的后果。Okay, here someone says some mention about my hometown. My hometown, Dunhuang, weather now change better and than before. Hot wave spread to the areas from south part of China because the grass to grow widely. Chemical particles and very active under high temperature. That is why water can be boiled to steam, and seawater can be active and under hot atmosphere, etc. And someone also anyway here we can see it caused a lot of effects. About extreme direct temperature effect. One is increase in average temperature, more extreme heat waves during the summer, less extreme cold spells during the winter, and harmful to those with heart problems, asthma, the elderly, the very young, and the homeless, here I mentioned when I went to Pakistan, a lot of people died from the asthma in very hot summer in summertime, and so not everybody can survive in when there are a lot of more extreme heat waves during the summer. And extreme events also including heat waves, cold waves, droughts, global warming will cause an increase in the frequency of extreme events, more event-related deaths, injuries, infectious diseases, and stress-related disorders. All of these diseases are caused by global warming. And climate sensitive diseases increase the risk of some infectious diseases, particularly that appear in warm areas, are spread by mosquitoes and other insects. And malaria, dengue fever, yellow fever, encephalitis, algal blooms occur more frequently as temperatures warm, particularly in areas with polluted waters. Diseases, cholera, accompanying algal blooms become more frequent. Today a lot of our clients, maybe for our Suntrans clients and today's audience, a lot of them are from mining companies, we know, and some are translators. For translators, usually we will travel a lot of countries. We know when we go to Africa or South America or some Southeast Asia countries, we can say always we must have a yellow fever certificate. That means if in these African countries, some developing countries, malaria, dengue fever happens a lot. A lot of people very easily suffer from these diseases. So all of these diseases are caused by global warming or climate change. So and in some hot areas, mosquitoes are allowed. We know mosquito may beat us and infect us with a lot of diseases. So all of this about climate change. Joe, would you like to also talk about some diseases caused by because of the climate change?
Well, so a couple of things that I think are interesting about how we think about climate change.
Yeah.
There's a very, I don't know how many of you are familiar with him, but there is an American philosopher and scientist. His name is Noam Chomsky.
Mm-hmm.
And one of the things that he says is crazy is look at the response to coronavirus.
Yeah.
When people with asthma and elderly are harmed by this virus, the governments react.
Yes.
They say, we're going to take care of this. We're going to get masks. We're going to quarantine. We're going to, try to find a vaccine. We're going to address this now. And they treat it almost like a war, right? A war on a virus. They mobilize, they get the military, they get the doctors, the nurses, everyone, and they make it happen. They just do whatever it takes to make it happen. Well, think about what one of these slides just mentioned. What does climate change affect? It affects the elderly, the young, asthma, people that are vulnerable. But do you see any mobilization? Do you see governments really saying, let's attack this problem. Let's get all of our resources now. Let's take this seriously because we don't want to lose the vulnerable, and we want to make sure that we solve this problem, but they don't do it.
Yeah, you're
not
right.
The same. And so Chomsky says, why? Why, when climate change won't just kill 3,000 people in China, it won't just kill 12,000, 14,000 in the US, it will kill millions. And it's going to be just as brutal, just as ruthless. It doesn't care how rich, how poor, what nationality. It happens everywhere on the planet. And so he said, why? Why can we not take this very serious problem more seriously when we take a problem like a single virus, one, very seriously?
Yeah.
But not a global
Yeah.
climate issue. When
yes,
I see these
you're
slides,
right.
I go, wow, that's we need to be more serious about this problem.
Yeah. Global warming, that means all climate change will produce a lot of diseases. Maybe one at the very beginning of the outbreak of novel coronavirus, I was wondering how SARS 70 years ago, how SARS disappeared suddenly. At that time, human beings still didn't innovate some special medicine or vaccine, but just because of summer vacation, summer came, then all of the SARS suddenly disappear. We don't know what's the reason. Maybe the global warming will produce some disease and also kill some diseases. I'm not too sure. For some diseases, at least for warmer places like some African countries, there are a lot of cholera, malaria, and because mosquitoes are a lot, they can infect people very quickly, and more different different bacteria or virus may occur in these places. But sometimes we are not too sure. For some, at least for SARS, that is novel coronavirus brother, they suddenly disappeared in summer vacation. But this time,
one of the things they're worried about.
This time,
one of the things they're worried about.
Okay, please.
It's the evolution.
Yeah.
So when you look at the sisters,
mutation and evolution happened to novel coronavirus. These days, some scientists have reported this.
That this thing will adapt.
Yeah.
And that maybe warm won't get rid of this warmer weather.
Yeah.
Maybe the conditions that affected the old SARS won't get rid of this version. And that's their concern, is as it learns, as it adapts, will the next pandemic, so let's say even if we're lucky and we control this one, will the next virus be even more difficult to defeat, more persistent, more temperature resistant? They're very concerned about that.
Yeah, here I want to tell you several things. Firstly, let's see about today's number, about the number of coronavirus patients. Globally, the number is 1.7 billion, more than 1.7 billion coronavirus patients. And in America, that is about 500,000 patients. And in America, about 17,000 people suffered from and died of the disease. And globally, more about 100,000 people more than 100,000 people died of the coronavirus. And in China, about 3,300, more than the number, people died. And anyway, a lot of people died from the disease. Some scientists mentioned, and I myself also wonder. Firstly, let's see the differences between SARS and coronavirus, the novel coronavirus. They are firstly about the mutations. SARS produce a lot of mutations when they are evolving and changing into different ways. But all of them, as long as the people were infected by the disease, they will quickly immediately died just a few days. But for coronavirus, people cannot die quickly, but will, even in the very beginning, without symptoms, it can exist in your in human being's body for a long time, and even 2 months later, it will suddenly you feel you suffer from the disease, and for novel coronavirus, it has a very limited mutants, but in the couple of few days, some scientists mention that it can become more and more easily to adapt human being's body. It can harmonious get along with our human bodies, and like a flu, and every year maybe occur. And but nowadays, even global summer is coming in China. The weather becomes warmer and warmer. Maybe the disease decreased in China, but in other hot places, it is still on the further outbreak, not stopped. I'm not too sure what's the reason. Maybe the global warming, climate change will affect the spread of novel coronavirus. Maybe accelerated, maybe decreased. I'm not too sure, because without currently we still haven't some very prestigious experts told us the results. Anyway, the climate change will affect bacteria. Roughly, generally speaking, malaria, dengue fever, yellow fever, and encephalitis, all of these, most diseases, virus, bacteria, will produce more and more with global warming. So I think in great degree, with the development of global warming, more and more diseases will suffer. People will infect people. Will be produced, and about an increase in the concentration, ground level ozone, and damaged lung tissue. So some organs also will be damaged just because just because of the air quality will be changed, an increase in the concentration, ground level ozone harmful for those with asthma and other chronic lung diseases. So when the global climate changing and warmer and warmer, it do a lot of harms to us. And food supply also be affected. Rising temperatures and variable precipitation decrease the production of stable foods in many of the poorest regions, increasing risks of malnutrition. That is because of global warming. In some areas will become very, very dry, like my hometown. Desertification and less arable land, lands so that people cannot plant more crops and rice successfully, so that less and less food available, and some people will become malnutrition. So food supply is very terrible. And about the population displace also happens. Rising sea levels, a lot of places and countries disappear, increase the risk of coastal flooding, necessitate population displacement. More than half of the world's population now lives within 6 meters of the sea. So most vulnerable regions, Nile Delta in Egypt, in Gansu Brain and Mapper Delta in Bangladesh, many small islands such as Maldives. Maldives is in Indonesia, where I visited last winter, or before the Chinese Spring Festival. The Marshall Islands and Tuvalu, all of these places maybe disappear, maybe covered by water, by sea water, just because the sea level rising. Okay, would you like to give some comments about this phenomena and caused by global warming? Okay.
Well, and not even before we mentioned the global warming part of it.
Yes.
If you think about Los Angeles, Beijing, Shanghai, over the last 2 months.
Yeah.
For anybody who's lived in these cities, what did you notice? You notice you could see these beautiful skies.
Yes.
That weren't there. You go, wow, am I in Los Angeles? I can see the sky.
Yes.
Normally, it's gray. It's polluted. When we dropped production to quarantine, the skies got more clear and more healthy than they had been in decades.
Yeah.
Everywhere. This is every developed country experienced this exact same thing. And scientists from satellites could see. If you looked at Beijing, if you looked at LA, you would see on satellite UV imagery, you would see a massive amount of pollution over the cities. But in February in China and in March in the US, you could see none, almost none. So the production, that was the biggest visual that I've seen in my life.
Yes.
How our production, manufacturing, and desire to have more stuff. We want the cars, we want the clothing, we want the furniture, but that comes at a very high cost. And we haven't come up with a great way to solve that yet. So as a result, you have people who have, you're breathing. In a city like Beijing, in a city like Los Angeles, you're breathing in all of these pollutants each day. And who knows in 20 years if you will need a respirator.
Yes.
You will need drugs to counteract the impact that it had on your skin, on your lungs. It's serious. Then, that's one part. The other part is the world already has trouble feeding all its people. In the United States, we produce enough food to help also feed a lot of Africa. But because of the government, because of regulations, much of that food will rot in warehouses in the U.S. It will never make it to people who could eat it.
Yes.
So we already have trouble feeding the population. And this is telling you that if climate change continues, we're going to have even more trouble.
Yes, you are right.
We're going to have less land,
and a lot of troubles we will produce.
population.
Yes,
It's not going to get better. It's going to get worse.
Right. Besides novel coronavirus and a lot of diseases and ultraviolet UV exposure in Australia, Sri Lanka, Tibet, Tibet in China, a lot of places, you can say they suffer from skin cancer and abnormal growth of skin tissues. So there is a lot of wrinkles. And you can say their skin not a lot of wrinkled and lesser, and some people become very easy premature aging, make the skin thick, wrinkled, and lethargy. And cataracts no longer have transparent lenses in the eyes. And in the lifespan in Tibet, because the sea level very very high, and they are very easy to be exposed in under UV ultraviolet. Their lifespan was much shorter than the average in China compared to other people. In Beijing, the lifespan was roughly about, the average lifespan is roughly about 78 to 80, and in Tibet areas, most people can the lifespan roughly about 50 or on average. One reason maybe just because they can live so short because economically it's not very developed in Tibet. Another reason maybe like UV exposure. Some people you can see their face. Maybe they are only 20 years old, but seems like 40 years or 45 years. Just because UV is exposure, very old, their face a lot of wrinkled, and their eyes, also is their eyes are destroyed just because no longer have transparent lenses. So maybe 3 years ago I went to Sri Lanka. A lot of people would like to the coast of ocean in the sand, and like the picture we show here, this land down over there seem very relaxed. Actually, sometimes just because it's close to the equator, that means skin cancer may happen to them. So UV exposure is very terrible, and some people other eye damages, skin cancer around the eyes, degeneration of the yellow spot also happens. Suppression of immunity, overexposure to UV radiation suppress the proper functioning of the body's immune system and natural defenses of skin. UV exposure or radioactive weakens the immune system, increases the chance of the infection and disease, and measures on the controlling of the problem. Here about UV, about the government factions, measures we can also talk about. Some governments have set some laws to limit the amount of pollutions produced by factories, develop the skill of using renewable fuels, for example, solar energy, wind energy, etc. And even in China, people use less and less coals, and in Beijing, most places have been in the past people use coal energy, but nowadays people use gas, natural gas, or solar energy. More and more solar energy companies are blooming, and government encourages them to use more new energy and wind energy. These are renewable energies. And encourage the factories to replace the fossil fuels by renewable fuels, which couldn't cause environmental pollution, carry out energy saving scheme, reduce the pollution produced by burning fossil fuels, build more plants, reduce pollutants. Here, a lot of mining companies have been doing this. They also must abide by government advocations. So measures on controlling these problems. And also citizens produce the use of plastic bags as burning plastic emit massive and recycle the resources plastic, reduce the use of sprays as CFCs would be emitted out. So low carbon life advertisements everywhere, even in Beijing, we can see in the Wudao subway station, we can see a big advertisement brand that is about low carbon life. And would you like to talk about some measures and in our daily life, maybe advocated by government?
Yeah. So before I talk about that, I just want to mention one other thing. Earlier you said the immune system. Our immune system. Think about that impact when we're dealing with new viruses. In the future, we're going to have less of an ability for our bodies to naturally defend if our bodies are affected by climate change. So we have two things same time. You've got climate change ruining our immunity, and virus that says, oh, you have lower immunity. It's going to be easier for me to attack you. So that's a dangerous combination. We should be trying to find ways to maximize our health. So that when a virus emerges, we are better equipped to try to naturally prevent ourselves from being infected. But that to me that really stood out as another important reason. Here we are right now, 2020, dealing with a major virus, and yet we're not taking care of climate change, which will help us to prevent these viral outbreaks from getting worse in the future. As far as the government, I think that I was unhappy with the last 3 or 4 years because the current government in the U.S. had stepped away from very important climate agreements. And I hope that next year, with a new administration, I hope that we will see a renewed interest in pursuing all of those relationships, because big countries, China, India, U.S., we are also potentially big polluters. So it's not Africa. In the middle of Nigeria isn't causing massive pollution. In the middle of the Congo isn't causing massive pollution. It's in Boston and New York and LA and Beijing, that we need to begin to take it more seriously. And so countries like China stepped up.
And in Beijing, our daily life, I found the government have taken a lot of measures, but not strict enough. For example, in our daily life, when we are trying to go shopping in the shopping mall, we can say more and more supermarkets advocates that please save plastic bags. You had better use cloth bags, and it is recycled. You can use many times. But if we use the plastic bags, although it's very cheap, not very expensive, when the plastic bags were burned, it will emit CH4 or carbon dioxide, and so it's not safe, and it will pollute the atmosphere. So for government measures, I think the government should take more measures and strict measures, not just advocate. And I know some organizations, several maybe even 3 or 4 years ago, I went to participate in some CEO or bosses seminars, and the coach told us, in future maybe a lot of the government will strictly take some measures, and for every company, we must calculate your carbon dioxide emission. For example, if you take how many employees you have in your company, for everyone, and for transportation from home to your company, and what kind of transportation tools you are using, we will calculate the carbon dioxide emission. And every company, you must have some index or indicators. Index, that means, for example, you must also plant a lot of trees, and that to compensate the carbon dioxide emission, and the direction is correct. The advocation is correct, but as my personal experience is concerned, the government the measures are still not strict enough. They advocate, but didn't implement. The implementation is not strict enough. So nowadays, people know low carbon life is correct, but how? Just say, green traveling, green transportation. But some people just know the concept, know the direction, but no practical behaviors. So that coach also taught us, for even you produce one mobile phone, and or a pen, must calculate how much in order to produce this pen or mobile phone, smartphone. That means how much carbon dioxide you will produce, and in future it's very important. Even he will encourage people to plant trees on the surface, on the top of your buildings, even a lot of high buildings. On the top, you will produce a lot of plants. And the government, if you plant more trees or more grass, that means will become a certain index of to compensate your carbon dioxide emission. And this will become very mature commercial models. And in future, everybody must remember to save energy, to use some recycle materials, and don't produce more carbon dioxide. And in future, I think we must be our government will take more and more measures, and very effectively and seriously, strictly implement the measures. Maybe our will prevent the happening of further global warming. Here is my suggestion. So anyway, reduce the use of air conditioner, which will also emit CFC. So for some government organizations, they suggest, for your air conditioner in summer, you cannot the temperature you cannot not make it lower than certain degrees. For example, 24 or certain degrees, this is the maximum, and you cannot lower than 70 degrees usually. some companies, some government organizations have make a lot of rules regarding how to use air conditioner, because air conditioner will emit CFC, and also use public transportation instead of private cars. As long as we can use subways or bus, we shouldn't use too many private cars so frequently. It will so as to reduce pollutants emitted by cars, because car fuels that stands for means carbon dioxide emission, and so that is very, very important. So here also several websites available for today. If we are interested in global warming, that is from United Nations and American government organizations, we can look on we can click these places as websites and know what will happen. So today our conversation has lasted about 2.5 hours. From 11 no, we got started from 11:10. Now is 1:30. 2 hours and 20 minutes. So would you like to summarize today's topic about global warming and climate change?
Yeah. So I think that you can see from anything you've already read, plus what we covered today, that
yes,
it's real. This is not fake. It's not some conspiracy. It's happening, and if we don't take it seriously, it's going to get to a point where it's going to be impossible to reverse the effect. And as individuals, we need to participate. As governments, I would like to say the individual can be trusted.
Yes.
But oftentimes, individuals cannot always be trusted to do the right thing.
Yeah.
So.
Yeah. Okay. I cannot hear you. The signal may be very not. Anyway, this is the end of today's conversation, and let me also summarize. Give some suggestions or propose several suggestions to our audience and some mining companies. For giant mining companies, usually we have like a BHP, Rio Tinto, Vale, and Glencore, and Barrick. All of these huge giant mining companies have set great examples for our other mining companies. We must invest more money regarding how to deal with or give response to the climate change or global warming. And our government, no matter China government organizations or United States government organizations, have taken a lot of measures to deal with climate change and global warming. And for just advocation is correct. The direction is correct, but how to strictly implement the implementation process is very hard. And hopefully all of our client, our private companies and small mining companies should learn from these bigger or giant companies, and our government should not only advocate people to educate all of the citizens, but also should take a more more measures strictly, and let people to be more knowledgeable for global warming, and also in future, and also more and more new commercial models regarding global warming will hopefully will produce, and so that we must concern the global warming. For some individual, maybe they don't care too much about climate change, but a lot of scientists have taken the related topics or themes very seriously, and they are searching how, for example, carbon dioxide burial. This is a very important scientific research direction, and a lot of companies also have taken very precious measures to deal with it. Have set great examples for us to learn from them. And anyway, today's conversation has lasted about 2 hours and 25 minutes. And let's meet the day after tomorrow. That is Monday. And thanks a lot for your listening. Thanks a lot to our audience and some of our friends like Lao Wang and another several friends from and clients from many companies and translation companies, or give us very positive, active feedback and interaction. Thanks a lot for your participation and listening. Thank you. Okay, see you the day after tomorrow. Okay, thank you, and bye bye.